Bill with Bill's Never Ending Projects, and the furnace is running and it's cooler out, so I'm going to do an inside project. I've got two Philco radios, one from 1946 and one from 1948. And the one from 1946 I'm going to fix for somebody, so I bought one similar from 1948 that I found on Marketplace for only $15, and then of course it was 100 miles away, so gas money, and that way I can work on mine in case I need to learn some stuff, which I'm sure I do. So what I've done is I found a Philco service manual of either 6 or 10 pages for the 46 model. It's called 46200, and mine's a 48200. They used the year for the first two numbers. So I'll go over and show them to you, and let's get the video started. The one he gave me to fix is better than mine. I didn't care about how it looks because I'm just using it to learn stuff. So even though this is 2 years older, it's in pretty much cherry shape, except it was missing the back. I can see mine's got a different knob, and look how clear the face is on there. Now look at mine. It looks like you can hardly see it. I don't know why that's so much clearer. It looks like it's because it's white. Mine's brown or something. I don't know. They both feel like some kind of plexiglass. I don't know. So, that's the two radios. I'm going to work on the 1948 first. It's always easy to tell because it's got this crack. Of course, the chassis is going to come off. What do we got here? There's the model down there, and the 121 is the code, so it's 48200. 48200 code 121. The other codes would be 120, I think, and then 125, and 125 has two different tubes in it. It says your guess is as good as mine. Or on the cherry radio, his stickers aren't as good shape. Yeah, they're not. Even the one on that tube there is faded. Mine's really nice white, so maybe mine isn't so bad, just on the outside. The story, I didn't know nothing about these, and I got this one first from Adam's father, and see, you couldn't see the, see how good you can see the model number? Over here you couldn't see it. I spent hours trying to figure it out, and I did figure it out pretty much. I just didn't know the code. And then I found out from somebody selling one on eBay, they showed the pictures of all of the top, bottom, and sides. And look at when you see the bottom. There it is when you look at the bottom. They show the exact model number, the exact code. His is code 122. Mine is code 121. I'll have to glue that back so somebody in the future won't have that missing. Yeah, and it shows the tube count. He's got a 50L 6 GT. For that one, I got a 50 A5 35Z GT rectifier, 35Z GTG. Well, forget the G on the end. It's just a 35Z 5 GT. 35Z 5 GT. So those are the same, except for that extra extra G, but that's a 7B7, that's a 14A7, that's a 7A8, that's a 7A8, that's a 7C6, that's a 14. I can't tell if it's a B. Yeah, it's a B. 14B6. Or it could be an 8. We'll find out later. At least Adam's dad's, the older one, the 46, don't have one that looks, you can't tell a 8 from a B like mine, but I see what I wrote here. Okay, it's a B. It's the second detector. Okay, well, I'm going to move his out of the way then. And we'll just work on mine. Well, anyway, yeah, that was the story. I didn't know what model it was, and I spent hours trying to figure it out. Then I seen that eBay picture, and it was here. It was clear as day, right on the bottom. Tells you the model. So if your ink's not as clear as mine, then just look on the bottom. And then these are the service manuals I printed out. This was just a short one, right from Philco, I think. And I don't know, they both could be Philco, but I think possibly one of them is that John Ryder. He does get the originals from Philco, and then he adds stuff to them, I guess. So I wrote the code number down on Adam's dad's one. It seems to be the ones that are always the most different from the schematic. And usually it's just the tubes. On mine, it's just on mine compared to the 125, the 121 and 122, it's just the two tubes that are different. Otherwise, the whole schematic's the same and the wiring's the same, you just change tubes. So, I think this book has the 125 in it, and if it's the same as mine, it's just the tubes that might be different. And then my book for the 48 to 49, Philco 48200, code 201. It's just one's in a walnut case, and one's in an ivory case, and then there's the one that looks completely different like that. So we're only talking about this model, and it's, of course, the walnut case. And their schematics do it in 4 sections. And I'm going to show you that. They start out with the rectifier section where the power comes in. And I've got it highlighted upstairs on the computer better to where the ground is and where the hot is, and exactly where the hot side is and the ground side if you didn't turn the plug backwards. And so anyway, this is section 1. It's not the RF or the IF. It's not the radio signal coming in from the antenna. This is the power section. So that's section 1. They don't start with section 1 here, or they do start with section 1 here. That would make sense. But then you'd think they'd go to section 2 where the antenna comes in. They go to section 2 at the 50L6GT power section, and then this transformer that changes the impedance for the speaker. So anyway, it's backwards. So I'm going to go from section 1 to section 4, where it comes in, and the converter. I'm going to go over all this. I'm just showing you the sections. Section 3, and then section 2. Section 3 is the IF section. Section 4 is the antenna and RF, and the converter tube, the mixer, and the section 2 is it's just one tube. This doesn't have two tubes doing it, it's just one. So that's the power. So we got the real kind of power coming in from the wall, the volts. Then we got the RF high frequency coming in with your radio station. Then we got, and it's being mixed. Then we got the IF, because now it's an intermediate frequency at 455. And then, so that's that section, and then sections of power. So we got the real power. Then we got, the AC power, turning into DC, it's a rectifier. Then we got the RF frequency coming in with the tuner. Then we mix it. Then we filter it on each side, and that's the IF amp. Then you have the power section. So let's go over that upstairs and maybe down here some. Yeah, I got this little booklet. It says it's 6 pages, but that depends what I have it magnified to. I got it from the yearbook that I just found out about yesterday. I got where I put it in my shortcuts, so I typed it in up here and it says it's there, so we'll click on that. Yeah, so this brought up just 46 and 47. But if you go over here, as you can see, you got starting in 1928 and going right up. So I went to, in this case, 46 and 47. And that brought me this one. And then I only want one radio. That's the, right here, the 46-200. So then I blinked on that one. And that's how I got the booklet. So the home radio yearbook library is what you want. That brought up this book, and the other one is the I labeled it. How many pages? I think it's two over here, up here, right here, I think. Yeah, it's 8 pages. So there's a little difference, and this book, it shows those two over there. This book, now they're over here in the top left, but I want this one. So let's go down to where I highlight. Oh, here's this. Here's the radio. Because we're going to get into how this works. And as you can see, there's 2 separate things on the tuning capacitor. I would call them gangs, but
they are gangs.
I think it's C301. C is for capacitor, but this is a mechanical plated capacitor. It's not like the electrolytic types or anything like that. Oh, these arrows are actually pointing to this one, the bottom down here. So 400A. So this is 400A. C400A and this is C400B. What it is, this one tunes your radio in. This one tunes it in 455 higher. So if you were tuning this to a station that was right on 1,000, this would be 1,455. I'm going to give an example with me tuning my home station in. That's AM 1360. I've got the numbers added up, and I'm going to show you how and what these tubes are doing. And I wanted to start learning a radio, how it works on an older radio, because these things are big, and I thought maybe it'd be easier to learn it. Anyway, this page is showing how there's these are all mechanical capacitors. This one has the mechanical tuning plates that overlap and then don't overlap as you turn it to get different capacitance to tune your station. These are trimmers, mechanical trimmers on each one to, well, this one it says, I got it written down, otherwise I wouldn't know. It's the IF amp trimmer to tune it exactly to 455. And what's the other one? Second IF. So this radio has two IF transformers to keep that thing tuned to 455, the intermediate frequency that gets made. I'm going to explain that. Later, I'm going to explain the RF signal path from coming in from the antenna through the tuner and so forth to get to the speaker. But none of that has anything to do with the rectifier tube. That would just be the other four tubes. So anyway, the rectifier and the power coming in is going to be a separate circuit. That's what we're going to go to now. The AC line on one side of the power cord goes to the on-off switch, and this one it's going to be the ground. The other side, forget the pins, they're wrong. But it goes to the rectifier tube. It starts the string filament and so forth. I'm going to show you that right now. Right there, I just got to turn it sideways. Did I do it? Yeah, there it is. And now I'm going to enlarge it and move it over. Okay, so I suggest you change these plugs so that one side is keyed. It'll be the wider side, I guess, they tell me. And, but check it on your own with your voltmeter. Because this side, if you got it hooked right, which would be the keyed side if you buy a new plug, will go to the chassis or whatever.
No, it's a floating ground.
Because I don't think they run a real ground system.
Yes, they do.
But I got it written down for it, just like it has a ground wire. But I think it's always just to the chassis. I'm not sure. I haven't taken it apart yet. So this side goes to the ground, and it eventually goes up here to ground. Every pin 7. See, except the detector. The detector and the don't run the same. This one don't even have a ground. It's kind of like a switch works. It just works with the hot coming in and going out. Comes in AC, goes out DC. And it doesn't even go out the plate. It goes out the cathode. The cathode's always right above the filament. These would be the filament, and that's the plate. Usually that's where your thing goes to the next section, because it's amplifiers, but this is not an amplifier, it's a rectifier. Detector tube is not an amplifier, it's a detector. So these aren't going to work the same. I mean, it does say there's a 7 here, and so see this dotted line? This is not like the other ones going to pin 7. It's because it's goes to the chassis without a wire, I guess. On all other situations, the dotted line means it's a container. So in this rectifier where the power comes in circuit, we've taken the ground, but let's take the hot side this time. It comes up and it gets split, goes through your pilot light to let you know the radio's on, and then it also still AC current running the filaments, and the filaments stay AC current going through all the tubes filaments. Notice it shows it looking like that, and that's the way it pictures them in the tubes, even on the other ones. There it is, it pictures it like that on all of them. So the AC stays AC for these, and then actually AC goes right into the plate, which is, like I said, completely different than how the amp tubes work that put power out or do a different job similar to an amp.
This puts out high voltage.
Anyway, the cathode is the one here that puts out the DC. I mean, you can use a book to explain. They act like the rectifier is a pretty simple tube because it doesn't even have a grid, so you could read up on it if you want. But anyway, I'm saying it's wired backwards. The cathode puts the stuff to the next section, and the plate doesn't. It's kind of backwards. It's just a one-way valve for AC current. Like I said, it's monkeying with the hot side, kind of like a light switch does. Here it's on the ground. See, all it does is open and shut. All this does is act like a one-way valve. So here we got DC,
High voltage.
and that's going to be the B plus line, and it feeds the radio. I only went so far highlighting it, if that even shows up, but then it goes up to the rest of the radio and feeds all the hots. I guess I could prove that by following one. Let's take this one. There we go, feeding them all. I just don't have it highlighted. And then all these feeds are going.
Every place there's a dot.
So you could pretty much figure it's not the one highlighted. So the highlighted one's the ground. This is the hot coming up. Yep. This one's a ground. So this. You're hot. Okay, so now how does the signal go through the radio? I'm going to use just my normal chart for that downstairs. Completely positive yet, but I'm thinking these are real fine wires that go around and make a coil, and then you can see the wire going down to the radio. That's got to be the antenna coil.
Loop, antenna loop.
I thought maybe it was on the back, and I'm missing the back on both radios, but that's good that it's not on the back, because I wouldn't have it. So like I said, the rectifier tube is kind of separate. It's not in the signal path. It's in the power path. Then you got the converter tube, or a mixer, but it It's the one that puts out that 455 signal. The IF amp tube amplifies that 455 signal. The detector that takes that IF intermediate frequency signal and unscrambles it, more or less. And then you get audio with that tube. So that's the list of the tubes I got. This is just 4 tubes we got to go over because this is separate and we already went over it. So your antenna picks up the signal, it goes into your tuner. L tuner's right here. I'm just going to use a picture so I don't have to keep holding this. So it's got the 2 sides. The side that C400A that does the tuning. So we're going to use 360 AM. I think that's what it is. I always turn to the. They also broadcast on a FM channel. It's FM. Well, I always listen to 107.3. So, but I think it's 1360. What you got to do?
Same channel.
So this one, let's say I'm turned to my station. I listen to sports talk on in the morning and in the afternoon sometimes. That's this one, C400A. C400B over here is going to be 455 kHz above this one. So it's broadcasting at this one. So there you got your two RF KHC signals. Now, what happens? They get fed. They both get fed into the 7A8 tube.
By different routes.
The converter.
One goes straight to the oscillator.
They both get fed in there.
Oh.
So it's like let's say it's like 2 strings on a guitar. You play them both, it's going to make a chord, and they're both different notes. So you get 2 different vibrations. And you also get and if you, let's say, tune those strings to the same note and then put one just a little off, you get some kind of harmonic or something. Higher and lower of the, so these 2, like I said, are making 2 different vibrations, and they make a harmonic or something. They call it a beat frequency, I guess, of, if you have to minus these, so I put this one on the top, that one on the bottom, you get 455, so it's the sum, which is the difference.
It's the difference.
Or is the difference just the difference? I don't know.
The sum's the top
You get 455 kHz from taking an 815 kHz and a 13 kHz and playing them both at the same time. Then you get that beat frequency, that's 455. And then that's easier to filter, it's cheaper. And so through the whole radio, after it goes through this converter tube, all you ever want to do then is turn your trimming capacitors, these 301 and 301B. They say there's 2 capacitors in 1 tube, so I don't know if they're both mechanical or not. I think they're both mechanical. I was thinking there was just 1 in there, but so they're variable. I don't know, but to find out, all you do is you look in the back of the book, and it lists what 301A and 301B is. Let's do that once now real quick. 3, I guess maybe that's why they call them 3 too. It's part of section 3. So section 3, first IF transformer, it's Z301. And it's C301 and A and B condenser trimmer.
They don't show any
And trimmers
capacity.
are mechanical.
They don't show any capacity. It would have been right
They
there.
put 2 in 1 can. But that's the first IF. So that you will, the factory tunes those so that you only get 455 because now that's all we need. So whatever station these two together turn, all you're ever going to want, because it's going to let the signal through it no matter what station you're on, at 455.
I never show the sum.
Section catches and processes the 455 signal called the intermediate frequency. For short. Seems real simple now, but it took me a while to figure all this stuff out because there's transformers too. And so you go through that tuner. That's the tuner. That's what we've been talking about on the back side of this picture board. You get your
It's the oscillator.
2 signals, and they both come into here. They get mixed. Then
Oh,
the
no,
oscillator,
that's the
when
tuner.
they say is the oscillator working,
Well, it's the oscillator and
see
the
how
tuner.
it's got that little bulge on there?
Oscillator frequency.
This is your oscillator signal. You're not into the IF circuit yet. It goes to this transformer, which is T400.
Oscillator transformer.
These are called, and that took me for a while to figure it out, these are called C301 and Z300. They're on each side of the IF amplifier tube, which is 14A7.
First
They're on
I,
each side.
first IF, second IF.
They're the IF section, transformers. This can, I guess it's in a can. Let's see, has it got a dotted line around it? I don't see any dotted line around it. See, these got dotted lines around them, means they're in cans. This one doesn't have any dotted line. So, but anyway, see that little, well, I know it's hard for me to point out, but it's easy for you to see it. See that extra little line right there? That means it's a trimmer. All these got the extra little line on them. Right there. And right there, it's just that extra little line. If it just had that, it'd be a variable capacitor, meaning you could change it. But in this case, they call them trimmers. I think it's even a T, actually. So, they're all that. They all have the T. So, this works. This is not in the IF circuit. This works to produce. Took me a while to figure it out because I thought all these. See, this is the same as this, but it's not in the IF circuit. All of these cans, I think, are the tank circuits and transformers. But they don't. They're just like coupling transformers, just like this end one. This end one, right before you go to the speaker, it's going to change the impedance to go down to this, from high impedance to this low impedance of about 4 ohms, 3 or 4 ohms. So, at least I'm guessing. I have no idea what it is. But so these transformers, tank circuit and a transformer, so they're kind of two things. So you see the transformer part. You can see the transformer part right there. That's an air gap. And then you can see your variable trimmers. And a tank circuit is an LC. It's a coil of wire and a variable capacitor. So, or LC is just L is for the coil and C is for the capacitor. So a tank circuit's usually just called an LC circuit. So these these here are all kind of like a tank circuit and a transformer all in one, kind of a little combo thing. And this is your IF. I put first IF, I have to cross that out. Crossed out, that's when I was learning this. Here's your IF on each side. IF transformer tank circuit thing. Title is just called first IF, second IF.
Immediate
And
frequency.
yes, they're in these tall cans with the holes to put your plastic screwdriver or something on the top. I'm not sure, I've never done it. Since I explained these little transformers and tank circuits, the tank circuit is filtering this to 455. The tank circuit is probably making the impedance like a coupler to go to this next tube. And same thing here, this is going to adjust it to 455 again. And this is probably going to make the impedance correct to go to this tube. And this thing, so we're practically through it. We brought the aerial, bought the
Loop in
music
time.
and signal.
It also has a
This
ground.
one made two different signals.
This has to complete a circuit.
1360 and the 1815. This one mixed it. It worked with this transformer called a later transformer, and they have a different signal path wired there with the shapes.
The oscillator gets sent up to the tube.
The impedance gets adjusted through the transformer, and the trimmer makes sure it's just 455. It goes through the IF tube and gets amplified out to plate. And it comes in through the grid. And there's your AC filament run down here, and this is DC up here, coming into the grid and going out. All these stay DC.
DC high voltage.
Stay AC. And so you got your
That's 90 volts.
IF.
That's a lot.
IF amplifier 14A7. Then you go to your other can. Your second IF does the same thing as this one, and they got it drawn real nice where it's sandwiched on each side. That's why I was really having a hard time with seeing that there were two transformers before it. It took me a while to figure out what this was. So it comes out to plate, gets conditioned for impedance to go into the second detector, gets adjusted again to 455 with that variable capacitor, trimmer capacitor. Then it's detected. It's turned from that 455, I just call it unscrambling it.
Into an audio signal.
Because I used to have a satellite dish, and you had to have an unscrambler to get the signal, but I guess it's not the same. It's called detected, I guess. And now it's going to be audio, normal audio. And I'll follow the wire later if I ever have to work on this, but obviously it has to go into this one.
It's actually,
here is again showing a ground. It's dotted, so that's another ground. That's the one we highlighted before. It's just touching the chassis, so they dotted it. Now how does the signal get over here? Comes out of it. Well, anyway, it'd take too long to go through the actual. It looks like it. See, that's the plate. It does come out of the plate. It shows two plates, it looks like. It goes down, over, and up. But and it comes in the grid. This is your 50 L6 GT output. It's your power amp. Or isn't it? No, it's not. This is the first audio amp.
Preamp.
I guess I didn't study that much to see the difference from a first audio tube to output tube, but this is boosting your audio. It probably boosts the unscramble the detected signal up so that
The audio.
I guess it's working like a preamp. It would make sense to me without even checking, but you can check this out yourself. So anyway, this amplifies it, and then it goes to your output, and comes out of the output. The 50 L6 GT goes into that transformer T200, and then it adjusts the impedance for this to lower this high impedance to this impedance of the speaker. I'm pretty sure this is going to have a magnet on it. Otherwise, it would be more than just this, I think. But we'll get to that when I get to it. I'm pretty sure. Uh-oh, what's this show? Oh, it's showing the to output terminal log on rear of chassis. Well, I hope it's not showing a separate amplifier to make like an electromagnet, so I hope it has a magnet. I think it does.
Or transformer.
Out. And for changing capacitors, this rounded side is the ground. I thought it would be the other way around, but the rounded side, like a frown, is the grounded side. Prove that. This is the ground I had highlighted upstairs. So there's the frown. There's the ground. Here's the switch through the ground. Goes up to this capacitor that shows a curved side. So ground, curved side. And on the power circuit side, do one more. So you got the ground coming over here and going up. And look, this branches off into a ground. And look at, there's the curved side. Goes to the ground. There's another one going to the ground side. Another one going to the ground side. So I would say the curved side is the ground. Here's where I found out what that little bulge means on the wires, on the lines that says oscillator signal. So that's where I found that out. In the darker lines, the RF or the IF signal. So I'm gonna go up and eat breakfast, and now that I got the signal path kind of figured out, I'm not guessing anymore, and I guess we'll plug it in. Why not? I do have a Variac now, and I haven't tried it. It's the exact same year as the radio. It's a 48, or it's a 47, or I'm not sure. For safety, I bought a isolation transformer. So got the tools, so everybody acted like I should have that, but it was expensive. I didn't want to buy it, but I did. Okay, I'm back on clarifying this T400. So yes, the signal comes in through the antenna coil, and it goes to, let me blow this up. Okay, that's better. So side A of the tuning capacitor goes right into the
Converter
grid
tube.
4 is what it's showing. But this one, it's side B on the tuning capacitor.
The schematic don't show the
See
wire.
this dotted line?
It goes to the oscillator
And it
transformer.
comes over here, and then it comes down here.
They just figure, I guess you'd know
There's that
it's wired.
T400 that was a mystery to me when I first started this. Didn't know why, because the other transformers are sandwiched on each side of the first IF amp, this side and that side. I didn't know what this was, so now I know a little more about it. The T400
It's an oscillator
is definitely the
transformer.
right here. It's T400 is called the oscillator transformer, and now I know what's going on. This other side, like I said, is dotted lined over to that T400 because it's wired separately to this. These are two different circuits. One is wired right here. This one just makes like this dotted line as a wire.
It ain't. That just means it's ganged and turns at the same time.
The dotted line means these both turn together, exactly together. But it's wired over here to this T400 transformer. And this that I said had these little designs on it, shows that this is a circuit going up to the converter tube 7A8. So this is like a feedback loop. So what it is,
it sends the 455 higher up.
it feeds the signal that's 450 higher into the converter tube. And it comes back with 4 signals.
No, I think it stays up there. It doesn't come back. It's a feedback loop.
That's higher. The difference that's lower, and the 2 signals that it started with. This signal from the incoming radio station, and this one that's just 455 higher that turns at the same time. So when it comes back, it's
no, it doesn't come back.
The trimmer.
It stays up at the plate.
And they trim all the other 3 out, and you only have the 455 from then on through the intermediate frequency transformers that also do the same thing, sort of. This one creates it, and then it's set at 455, and these filter the other ones out every time it filters it, and so that's more what this does. It's this goes into grid 2. This one goes into grid 1. This one goes into grid 4. And what grid 3 and 5 are doing up here, I'm sure there's a purpose. 90 volts and 45 volts. Again, the reason these need voltage, an electron collector, it needs high voltage to pull electrons across the tube from the cathode. That flow is what allows the tube to amplify the output of the mixed signals 455. So that's why it's getting 90 on that grid. It makes it so it can amplify the output of the mixed signals 455. Grid 2 is the screen grid, 45 volts. It sits between the control grid and the plate. It helps shape the electron flow and reduce capacitance. It needs voltage to do the job as a stabilizer guide. About one acting as a suppressor, I don't know what that means. Now I know more about how this gets mixed in. This comes in from a separate wire from this tuner. This one is wired to this T400 with a separate wire, and then they run back and forth,
feeding
creating what this does, the 455, that the RF will be the rest of the way to the rest of the way
it
to
comes
all
from
other
the
sections
converter.
until it's detected.
It comes from the converter tube though to
So
go to
that
the.
was a penta grid tube. All those,
Yeah,
5 of them,
it leaves there,
penta.
and then it goes to the first,
First
IF transformer.
Tube. It's 14A7. It seems to have 3. It'll be grid 1, grid 2, and grid 3. So here's grid 2 and 3. So then, yeah, this is grid 1 over here in the normal spot on the left. So then that's going to be a 3 grid tube. I guess this dotted line all the way around, it's the screen. The converter tube don't have one, but if you go right over to the IF, I drew a drawing of there's that thing going around there, the screen. And the detector is a different type of a tube. It doesn't have one. The audio, first audio, and then I guess this works like a preamp, I don't know, but this one doesn't have one either. So it's just this one that has that screen going around.
The IF amp.
For whatever that's worth. And it seems like all the cathodes are directly grounded. And this converter tube grounded. So I was thinking about the reason it must have 2 pins for the heater. Has to come in and then go out to go to the next one, maybe? In and out. Just to, I come back upstairs to add something, so when the signal comes in, goes through the converter, then eventually gets to the IF. That has a transformer on each side, and then it gets to this time to detect it. And every time I seen these 2 half circles, or 2/3 circles, I thought it was 2 separate tubes, but then I counted the tubes and I had 6. There's only 5 tubes. So what I found out is triode has 3 electrodes. The K that equals the cathode emits electrons, G equals the grid, controls the flow, and P, the plate, anode collects electrons. So you got the cathode control grid, and then you got the pentode. They add a suppressor grid and a screen grid. So that's a triode and a penta. So to the IF amp in the filtering transformer there, we have the second detector, and then see that AVC thing? This does 2 duties on this side, and this does 1 duty on this side. It's still called a triode, but it's called a combined high MU triode. And a double diode. So the reason I got P marked here, this is plate, and that's plate, and that's the cathode, and that's the heater. So the reason this doesn't have a grid is because it's a detector and it doesn't need one. So over here on this side of the tube, the same tube, it does have a plate and it does have a grid. This side has no grid, so it does have 2 plates. And this cathode always goes to ground. And on this one, the ground, when I was reading the chart, was called shell. And then it's because there's no wire for this ground. It's the shell must go to the
Must be what number 7 is.
base it's mounted on.
No, number 4.
So it's a 2-duty tube. So I now know that that's what I'm looking at. All one tube. And
I think in a tube checker you got to change the settings to check each side.
The antenna coil, the tuner, and the oscillator tuning capacitor, the converter tube that works with the oscillator transformer, the first IF transformer, the IF amplifier, intermediate frequency, and the second IF amplifier. The tube we just talked about it, the dual tube, the 14B6, that is the second detector, and the AVC, and the first audio. It's like a coupling preamp. Well, yeah, it is. So it's like a coupling preamp for this amp, and then you got the T200 transformer and the speaker. 200 transformer in front of the speaker is listed as the output transformer. That's
all it says.
That's all it says about it. And I forgot the power section. You have to scroll down to where all the grounds lead to.
Oh, we want.
The hots lead to.
I guess we're going over it again.
The rectifier tube. So that's the power. So that was a quick review, and the last one. Now it's time to do something with the radio. Finally. Well, good morning. I'm just trying to. Now that I got the bench cleared off, I'm just trying to see if they're all in order the way they would go through the radio.
The way the signal would go through the radio.
But it doesn't look like it is.
But it sort of is.
The far right is the second detector. The far right is the second detector. And the IF amps next to it. Well, you're not going to be able to see it there. I'll bring it up. So, if it was in order the way it went through the circuit, it should be the power. Yes, that's the that is the rectifier. Then the next thing should be the mixer, which they call the converter. Let me see what I got now next. Yes, I do got down the converter next. So that's the and the tuner. So it'd be the power, the tuner, then the
converter,
the 7A8 converter. Right here, easy to see. Then the one way in the back. Next should be, I'm looking on the schematic, should be the IF section.
No.
So let's see what I got.
The back one. The back one's in a different row.
Nope. It says 50A5 speaker output.
Yeah, it's the last two.
So that's not really in order.
So
way back in there.
Yeah, that's why they put it there. It's the last two.
Then let's just make like they didn't put that there. So the next thing would be the IF amp. And that is what's here, the IF amp. And then the last, after the IF, would be the detector to take the signal out of it.
The dual purpose.
Unscramble it, I always call it, but that's not really right.
And it's a preamp, all in one.
So really the power amp back there should just be over here. Then they'd be all in order. So they are all in order
Very
in the
good.
back row.
Very good.
The back row. So it's the 35 Y4 and the
No, I have a 35Z5.
power supply.
It's a
They call it a
35Z5 GT.
rectifying tube. Then the tuner. Then the converter. And then if you don't count the power supply, it does go in order.
Very
and
good.
Then the IF amp. Then the
Detector.
that's the dual tube. It's the second detector. And the first audio.
Preamp.
And the AVC. So it's a dual tube. One side's the AVC and the
Automatic volume
AVC
control.
and the detector, and the other side of the same tube is the preamp. Preamp they call it the audio amp, and it's the preamp to that one way back in there. So now I know the order. Took me all morning to clean the bench here, so I'm gonna go up for dinner and I'm gonna come back and we're either gonna take it out of here. I suppose we could plug it in first, but no, this cord will plug into the isolation transformer. But where does the dim bulb come in? I'll have to research that. And the variac. So I'll have to. So there's something has to go first, second, and so I got 4 items. Got the dim bulb, got the isolation, got the variac, got the radio. So I'm gonna see what order while I'm eating dinner. While I was eating, I looked up so I could put the variac into the wall, which it already is. Then I should plug the dim bulb tester into that, so you have your current limiter, kind of like a visual fuse, kind of. And then I could put the isolation into the dim bulb, then the radio. And I learned one other thing. Most of these were called, oh now I forgot the word, starts with T, it's a tritone or something. It was an advertisement they used for selling them. Oh yeah, there it is. I didn't ever notice that before. Transitone or something. Yeah, I never noticed that before. Let's see if the 2-year-older one has one from 46. Take a look at this one. It's not that one. It's this one's cherry on now. It's meters. Oh, there's the name. It's on the top part. Transitone. Okay, it's in there. Look at my card. I just wanted to bring this up. It looks perfect. It looks in perfect condition. Now we look at Adam's father's. It's all frayed there. Look at that. I'd have to separate that. I'd have to change that before we could even turn that one on when I get to it. And on my radio, I learned one other thing. Right here where it says model 48200, code 121, it says 115 volts AC or DC. So this is back when Tom Edison still had maybe Chicago, New York, or whatever. I don't know when they changed over to AC, but this doesn't mean you have a switch to switch it on to batteries and then back. That means the whole city would still be on DC. So it would take either AC or DC. And then when DC came through, the rectifier would just go straight through. The Variac does have a keyed spot, even for 1947. On my dim bulb, I did put a really nice cord on it, or else I cut off an extension cord. It looks a little bigger than a lamp cord. Yes, it does. So I'm gonna have to go find an adapter. I don't know where I'd have one. Guess I did find when I took it off on a stereo where I'd have never found one. This seems to be keyed. This side's the ground. These side are the same, so it should fit. Well, even if it was keyed on this side, it would fit. So I guess I can plug in the dim bulb now right in here. So get that done. So this won't work since it's not keyed on this end, and I have no idea. Well, yeah, I do know where the ground is. It's the bigger one. So it's this one. So I gotta get one that for sure has a keyed side. I'll have to go to the hardware store. Yes, since it's so far to the hardware store, like a 15-mile round trip, I'll just take this apart and look to see which side I have on the ground. That's what I'll do. According to this, the one on the left, since I have a neutral or whatever it's called, ground, the one on the left, the larger one's the ground, so I'm going to try the one on the left with the ohm meter and see if it ohms out. Just had to take out those 2 screws. Geez, I forgot about making this. Looks like I welded a plate to there on each side. So anyway, I'm going to use the meter here and make sure that this left side blade is a ground. And then if it is, I'll just mark it down that I checked this. And I can, just because this is here, then it has to always stay this way. So it doesn't matter if it's marked, just so I know that I got it right, because I wired this. Okay, this meter, when I touch these together, goes to 1.2. So goes to 1.2. I don't know, or yeah, 1.0. So I'm going to try the left side. Going to try the left side here and see if it'll go to 1.2 by touching the ground side of the plug. It does. Now let me touch the hot side and make sure I get nothing. There it is. Nothing. Okay, so I wired it right. Okay, so I can put that back together. Written right on the dim bulb receptacle. So I know I wired that right because I just checked it. This one's, that's the ground side. Because I just wrote it on there. And with this thing, even though it's not on the bottom, turned that way would be the ground side, and this one's the ground side. So, okay, now I'm sure those all have a ground. It's going to have the ground if I turn this the correct direction, which I did. Ground's on the bottom, and I marked the top, so these are the hats. Okay, so the next thing, I got to plug the isolation transformer into the dim bulb. Okay, I see it here. It's coming out. It's coming out at the top, right there. So it's this cord right here, all neatly tied up. So I'll just unplug it from here and go there. Oh, it's gonna hit the light bulb. I'll have to untie that bunch. She's neat just to have to untie it. Oh, maybe I can put it back in and just let one of these go. That's what I'll do, just let one. Okay, now we can get it in there. Still gonna touch the light bulb. There. It's off. This is on, off. Now it's under the cord, but it's on off. This on off. And that thing, I yet to plug the radio in yet. So, yes, next up, plug the radio in. Everything from here down is isolated in that border, so these are it. Oh no, what do I got now? Of course, the radio I don't know unless I put my new polarity plug on it. Maybe I should do that, I bought one. Well, for now, I just won't touch it, any part of that. And I'll put it in. Oh, is this key? That don't look any bigger than the other one. Let's see. I don't know. Or get it off camera. Measured them, they're both 1/4 inch. So, doesn't matter which way I plug it in because I will never know which is which. One side must just be bent, although it is. I see it now, it's up near the top. I'm going to straighten it. That should go in there. Oh yeah. Thing has enough weight not to hold it with my other hand in the back. So now, this has got a power switch and that was on off. Okay, so first I have to power on the power. It is. Then I have to this is going to be on 0, so I'm just going to put this on. I'm going to put this one on. And then let's see if this thing here clicks or something. Yes, it does. So I'm going to put that on, just on, with no volume. Then well, that's it. Everything's on.
No, it's not. One left.
Power's on. Variax not turned on. Oh, it's humming. A little bit. Okay, so the radio's on. This is on. So all I have to do is turn this up a little. I guess I could measure what this wire's for. But, okay, let's crank it up some. I'm going to just give it like 30 for a little while. I'll bring it back. A couple minutes. I heard this lady plugged it in because she thought she'd get more money for it if it worked, so I might as well just turn it up. I'll leave it on 60 for a second. Okay, now 90. Oh. Oh yeah, so here's 60, you see nothing in the dim bulb. And then there's 90, so it's pulling something. I'll leave it on 100 for a little bit. I don't hear anything. Okay, I'm going up to 115. Or 120, it's not probably going to have a 120 anyway because of the dim bulb. Well, that's not too bright. So there isn't any dead shorts. Then I might as well put it on 120. There it is. Okay. Let me cut the lights, see if we got tube glow. That's the rectifier's glowing. So is the converter, but not very brightly.
I should have felt them with my hand.
Oh, that's a reflection off the dim bulb. That was a reflection off the dim bulb. It's dim, but it's still making light. I guess I could turn this the other way. No, the rectifier is the only tube lighting up.
No. Well, I think it's a reflection I'm seeing, but
these aren't metal tubes, are they? If they're metal tubes, you don't see them. Okay, so now we're staring at the tubes. Let me move the dials around.
I should have felt them.
No static.
I did crank the volume up.
So it's totally dead. All right, let's get it unplugged and get the case off it. Looks like 3 screws. So one of these fits. I can just buzz it out. Nope. Quarters always use the one and that in there. It's somewhere, but I'm not going to look for it today. There's a driver in my leaf spring saddle. So, yep, it's a quarter. Here we go. Okay, I'll get this off. I pulled it right off, no problem. But, uh-oh. I see a screw in there. Okay. Homemade. At least they put one on there. Okay, so out there is not a screw. That's some kind of
piece of metal wrapped around.
Yeah, it's a wedge. And a piece of wood or something. What the heck?
No, that's the shaft. That's the shaft.
Well, we'll see what it is when I get it out.
It's cut off shorter.
That one sticks out. This one isn't going to be sticking out as far. They might have cut it off. That's got to be the shaft. All right.
Very good.
I'm going to get a pry thing.
You notice
it's coming right off. It's held down by the right amount of tension. About the same as the other one was. Oh, they folded over a piece of metal. And then they use this.
Must be a dresser knob.
Must be a knob off something. Oh, that's what they used. I got the temperature coming up on the Waller. I had to go get my solder station. I was cleaning off the bench, so that was over there behind me. Comes up real fast. What we got to do is this antenna that goes around here is hooked right here to this little, well, it's not a PCB board, but it's just something they rivet on these chassis to stabilize stuff.
Screw.
So, yeah, we're up there. Okay, well, let me get that off. Okay, that's free. Put the camera down and turn this around. The speaker's not ripped. Yeah, okay. Side looks good. I'm sure that bulb is burned out, or the filaments couldn't have lit, or could they? It's in line with the filaments. The cord looks hooked up. Let's turn it. Oh yeah. Yeah, I see the plates moving. Okay, so I can either test the tubes first. I've never even used my tube tester yet.
Yeah, another rabbit hole I have to go down.
Look underneath
to find the tube
tester.
tester.
Got there. What the heck is it?
I never figured out what that is yet.
It's got potting on it. Is it epoxy? Huh. So, this cap is hooked to the side with a strap.
Okay. So, let's either check the tubes. I think I'll get the tube tester. This is the capacitor wizard, and it has 4 AA's, and this one checked like only just a hair over a volt. There's supposed to be 1.5 volts, according to that right there. So I'm gonna get 4 new batteries over there. These, oh, they look good. Kirkland, what? Oh, I put these must be some cheapies from something else I put in this. Maybe I won't use them. I didn't have any other ones, so I guess I'll use these gray ones. Okay, positive another one. Positive on this one. Okay, I should have it working now. That seems to be working now. I'm going to check the capacitor right now. Yep. All right. Got a capacitor wizard again. Whipped this out of an old 60 stereo and still says it's good. ESR wise. ESR wise. Check this 10 microfarad. You might be able to see it. Okay, 10 microfarad. It's called the Doppler. Doppler Club. Boy, pretty bad, huh? No good reason to check any of these. It's a 1948, so I want to get this unhooked from this outside thing here and see how many capacitors are inside here. It wasn't hard to get unhooked. Forget that one. It's hard to get it. Okay, let's see what we got in there. Looks like we got a... Let me grab the thing and pull it out of here. It's harder when you hold the camera. So it looks like we got a 40, 20, 40, 150 volts, 20, 150 volts. I was kind of getting blinded by the light. 240s. 240 by 150, 40 microfarad and a 20 microfarad. They're all 150, so I need a 40, a 40, and a 20. See what I got. Sucks. It says I have. I don't think I should have put those dots. A 30, a 25. I shouldn't have put those dots on there. Oh, but so I need 240s. So the 47 I could use probably, and the 22. So then I got two of the three. So I just need another 47. These are axles. And go ahead and look in those cabinets. So I'll do that off camera. Well, it turns out there's a 47 by 250 right there, because I was reading down here 50 volts wouldn't have done it. 100 volts either, but it says I got 250 to do it. These in here are 400 volts. So I'm good all the way around. This big filter capacitor, I think that's what it is. Somebody's already restuffed this maybe, because this is probably a new shrink tube. And but where did they get these little plates? Yeah, I find out
each
later.
end.
I find out later those are factory sold.
I don't know anything about that, but I don't think they had shrink tube. I'll have to do some more research. And they wouldn't have used two reds.
Yeah,
They used two reds and a blue.
They-
They would have used
they
three
actually
different colors.
they actually did
These
use
all
two
beeped.
roads.
Thing went way up to here and beeped on one of them, and the other two it went real close. So I think I'm going to put this strap back on. I think this one's been done.
Yeah.
This guy, this is another guy's radio. He does have the two same colors,
That's how I found out.
and he's already cut them off. And there's the things I thought were shrink tube. And there's that plate. It's probably not even metal. I'll get a magnet. But he's had somebody replace his, and they did this fine job. Or
That's a bot. It's a
or
bot.
this is factory. I'll find out. But at least I've got some light shed out of it. Now another guy with a 1948 has the same two wires, the same. This is a 40, 40, and a 20, multiple section capacitor. So and he does have the same two wires and the one single one, because these are the same capacitor rating. So what would the difference be which one you used? And the ground always comes out the other end. So he's got a good idea. He says once you pull the tubes out, you draw the keyed part, the little keyed part on each one.
And
These are different tube names. They're his radio. You draw that little key thing, and then clockwise, it'd be pin 1, 2, and so forth. So find the keyed thing right there. This would be pin 1, 2, and 3, and 4 clockwise, because you can't see the keys to get the pin count, because you always have to count from the keys. So you can't see the key because it's so clouded with wires. So if you made your own little chart, he's saying, I think it's a good idea. So when your tubes are out, you can see right where the key is. See, it's right there. And it's right. Well, you can see it, because you can see that one. So therefore, I got to get the tubes all out of mine and draw up these sheets and then test the tubes. Back on my schematic, he also made a good point. If you're gonna put a keyed side here, so you got this always neutral, that means the way they did this, they have the switch on the ground side, so it's going to leave the hot side hot all the time when you got to shut off. So maybe if you were to touch the chassis, you'd get a shock, big time. So this switch isn't going to move because it's the knob and the mechanical part, but you could take the wires off and let this ground just go straight through. And then you can wire it so the switch is cutting off the hot up here. So now the switch should be up here instead of down here. So I'll draw it here. And open in there. And then we take it out of here. And then it will just go straight through. And good thing I did some more studying here and listening to people. I'm looking for my tube tester. Here's a case. No, it's the Beltron picture tube restorer. So that won't do. Back to hunting. Well, it was sitting 3 feet from where I was standing. It was sitting right under this.
LCR tester on the Scott receiver. So, but this is an hour later. I checked everywhere. Of course, it was right here. I haven't opened it, but this looks like the right size. So, let's open it. See what I bought a few years back off eBay for, I hate to say it, but I think I remember a bid war with somebody, and I paid about $150.
But it said it was a working one, so they usually do go higher.
$257. So I'm gonna shut this off, and I'm gonna. First off, I haven't even pulled the tubes out of there yet. I have to learn exactly how to wiggle them. And I guess you gotta pull from the base down here, not up here. These are just glued. And they're probably kind of hard to read. So maybe I'll mark them with a little piece of tape. So I got some work to do. And I'm gonna cut some cardboard. I'm gonna make 2 layers with a cereal box and use some ties to go through these holes and cover the speaker. Okay, I got the paper cardboard cover on the speaker. Now we can flip it around. Oh, gotta pull the tubes out of it. Okay, well I'm gonna use both hands and rock these or whatever I gotta do. I'll have to learn to get them out. Okay, I got this one out pretty easy. I can, a little bit of a mark on there, I can sort of read it.
So I don't have to mark them.
It should say 14B6. So some of them got rust all over them. So for these, now you can see through the bottom portion, but look how burnt that is. So I don't think some of these are going to test very good. Let me get them all pulled out of there. Yeah, I was supposed to put my fingers down by the bottom, but I pulled on the glass because I couldn't get them in there, but still in one piece, so. Yeah, you can't get your fingers down in there, so I guess I'll just have to hope they don't break. Jeez. Okay, I'm going to put this on pause and make sure I can read these. Yes, I can read them all so far. Not good, but if you stare a little. But this one, that's too much rust. I'm going to have to pause and see if I can get some green pad or something and rough it up a little and see if that'll make it so I can read it. Otherwise, I got to use tape.
Now I think I'm taking the writing off it, at least dulling it down.
Perfect, now I can read it. I could do that to the rest too, I suppose. And the last two.
That's the one with the little star thing that was next to it where I have to wiggle it different.
I think this one comes out different. I gotta read something in the book. Read what it says here on the bottom of the radio. That's what it tells you. Yes, right there. There's a little star. And I'm going to read what the star says. It's only on that tube. It says the tube's marked with a star to rock with a circular motion. I thought that's what I was doing, but rock with a circular motion.
No, I was just going back and forth,
Yeah,
north and south.
I guess reading that helped because it's just black on this end, and I don't see any writing. I'll rough it up anyway. There it is. It says it on the side there, 35 Z5, and the GT is down lower. Now to figure out tube tester, Accurate Instruments. I'll get this off camera. I'm pretty sure we'll be using this one marked number 8 because while I was studying, I'm pretty sure I heard the 8-pin thing enough.
Except
Right.
except that
This
eight don't mean 8 pins.
It's way bigger than this shaft.
I didn't know that.
Okay, so that's not the right one. On the fit, it is at number 8.
It just
I gotta learn to take it out of here even. But
it just happened
this
to
one
fit.
seems to be different. Remember, I had to take it out differently.
Yeah.
So I'll have to look in the book and see what's going on with it.
Learn.
As you can see there,
Learn as I go.
that's the one with the star where I had to move it
No,
at 360 and
that,
pull up.
no, it was this one.
Kind of around like that. And these, I guess you just go back and forth.
No,
that one around.
This one you go back and forth.
Kind of move it around, and that one back and forth.
No, opposite.
And they're totally different. This one's big and fat. Oh, but it's on carpeting. So I'll have to read up to see where this tube goes. It's the rectifier, the power supply. After grabbing these, I found out all of mine are like that, except this one, and that's the rectifier. So it's the rectifier. The rectifier, the 35Z5 GT, is the only one that fits in there, normal, and doesn't wiggle. So I'm supposed to either have to have an adapter, or do I just put them in there? But the pins don't fit tight either. So you can't tell, but these pins are obviously, okay, now I can tell. Those pins are definitely fatter. So I'm gonna have to get an adapter. Let me go upstairs and research this and see when it'll be here, and how much it'll cost. That was its tube substitution book, so it did give me 4 different tubes I could put in for this rectifier. So let's put that back.
I wouldn't.
This one out. It would have been this one.
I wouldn't need it for the rectifier because that fits.
Okay. Maybe that one will shed some light on this adapter. I could test the 35Z5 GT then. It says F, you don't do nothing. G and K, I put them on 5. And 8, which I've got. 5 for G, and for K, I got it on 8. There's the short light. Power is on. Short light's not coming on. So then it says I can go further.
See that 6?
For some reason it says 30 here on the load.
I'm glad I didn't wreck
And
it.
it says it has 6 pins.
I got it in the wrong socket.
That was correct. It had 2 missing.
That's not pins. That's the tube tester socket.
I go back to the cover. It says this test will indicate over 95% of the shorts which occur in most tubes. So I passed that. That light is not on. As if the tube is shorted, it should be discarded. So I'm going to go to the next one. Oh, if the tube is not shorted, move for the press quality slide switch for the quality position and read the tube quality on the appropriate analog gauge. Good, bad meter. Top of the good to bad meter scale is used for most tubes. If the meter reads in any position of the green, it's good. The tube is good. If the tube chart listing for the tube is preceded by, that's what I had to do to turn the tube kind of 360 to get it out. Read the bottom of the diodes. I don't have that. Doesn't have that little star. Sounds like I have to press this for quality and then read this meter. So here we go. I'm going to be pressing it. Watch the meter. Nothing.
Yeah, it's because I never used this before and I don't have it in socket 6.
Well, since I only have one tube to test, I'm supposed to keep this on regular unless otherwise told.
I'll figure it out eventually.
Okay, so I can't learn much with this. If this tube is bad, maybe that's why it's not doing it, but I have no other tubes to fit in here. I guess I have one TV tube. Let me go get it. Box says it's a 5U4GB 5A S4A. So I'll have to look up those numbers and see if it'll fit in here so I can test this tube tester. Okay, the 5U4 socket C, settings 12 and 14. I got it on C and 12 and 4.
That's not socket C though. I don't know what the C meant.
5, 4, 12 and 6. Change that. Okay, turn it on.
I probably got that one in the wrong one too. Luckily I'm not burning tubes
And
out.
yeah, that tube also had the big black plastic thing.
Octal.
So I'm able to test it.
I know now.
Okay, it doesn't do the short light, so let me pull this and see if I get nothing again.
That's an octal base.
Oh, okay, so that other tube is really dead.
Well, I guess they didn't lie when they sold it to me.
And this one's
It's a working tube tester.
That's good. So, the tube tester works. It's just I only have one tube I can get in there without an adapter because all these are these tiny
lock
pins with a skinnier shaft.
They're called Loctol.
So I gotta go up and see if I can buy an adapter, and the tube tester seems to work. So I'll put this away. Yeah, go up and see if, I don't know, this book doesn't say anything about how I test those, so I hope somebody has something written up on it. So I gotta redo the 35Z5 because right there it says socket 6. I didn't realize this octal socket, this turned out to be octals, what these take with these big plastic pins. And this tube will, this rectifier tube will fit in 4 of these. It'll fit in this one, this one, this one, and this one. I still have no luck. The only ones that even be close would be those, and they're not keyed. So I got an adapter coming from these, but then the other problem is they're not in the book.
They're not going to be in the book.
Not in the book. So anyway, I had this in the wrong one. I had it over here. So let's see if it'll work now. Yeah, it's getting warm. So let's see if it'll work now. Still, it doesn't have any shorts, so let's push this down. It's got to be warm by now. It's not hot, it's just warm. Oh, makes all the difference in the world. So, it's good. Okay, so now I just gotta figure out how to test those other tubes. I'm doing research on it. Okay, I'm drawing my tube sockets, 8-pin. Putting a few references like the speaker up here and the pulley on the dial plate and the tuner.
Don't put those there. It takes up too much room.
The gang tuner where the
that's where you want to draw your wires.
Oscillator tunes the rectifier, and this side tunes the RF. So I got them. I got my pin things. This one seems like points right through there. Let's see. here two of them point the same way between about 4 and 5 o'clock. This one points like it's 7 to 8 o'clock. This one's around 1 or 2 o'clock. So's that one. So now I copied them from the radio, then I tipped it over. And then when I tip it over, it obviously goes over the other way too. So now when I tip this over, yeah, you can see them. So now I got to trace over. I got to trace over what I did, and then that'll be the way the radio's sitting. So let me trace those. I added a little dotted line there so it's quicker to see where the keyed pin is of the tube. So now I got all this white area where I can write down where I take a wire off. So let's turn this. Turn it back to the radio here. So what I found out from taking more lessons from the internet, this is a bought one, it's not a factory, because mine calls for like a 30, 25, and a 20. And I think when I had that out, it's like a 40, 40, and a 20. So it seems like everybody's radios that have this replaced. So if this was made in 48, probably in about 1960 or so, somebody replaced this with a factory one. And then they're using shrink tube by the 1960s. Maybe it's from 1970. I don't know, but that's a replaced one. So I was right, it's not factory.
It's a bought and replaced.
And it's probably been replaced so long ago, we're just gonna change it anyway. This would be the electrolytics, 3 of them, that come right behind the rectifier. The 41st, then the, would have been the 30, 25, and 20. We got 40, 40, and 20. I'll probably stick with 40, 40, and 20. Maybe to filter it better. But it comes right after, it's in the power supply, and it comes right after the rectifier tube. Have a capacitor, try to do something without a resistor, and you can have a resistor do stuff without a capacitor, but when you put the two together, you get an RC kind of a filter circuit, and that's what's going on. As soon as the 35Z5 GT meaning glass tube, rectifies it, then you get hit with these 3 capacitors and a couple resistors that keep cutting it down, getting it ready to go to line voltage, but it also does something mixed with the capacitor, so it's a resistor capacitor filter, after bypass filter after the power supply. So we're going to change that. Okay, I got these, I can't read them, but I want to write down on this piece of paper. So I'm going to look on a schematic and see what they are. I'm pretty sure they're capacitors. So let me do that. It is. How long will it take me to find the volume control? I'll do it off camera. How long?
I never did find it.
Okay, well, on the piece of paper, it's here, and the detector is right here, 14B6. So let's go to the volume and the detector tube 14B6, and I'll follow these wires. They go to the detector
I can write down.
14B6, and I'll find out what pin they go to. Then I can find the wire on the schematic, because I couldn't find it. Would have to be the split tube. It does 2 purposes. I did have a sheet made up for every tube where I went on to a site that would bring up the exact tube pin and everything, and then I wrote it all down so that when I went to pin 2, I'd know I'd be going to the plate. Added all the numbers to my paper so I can write down the wire. If you're looking at the bottom side, they go clockwise from the pin. I think if you're looking from the top of the chassis, they go counterclockwise. Now in this this little free service manual you can get. Through a couple pages here. Show you some pins here where it says troubleshooting.
Yeah, so this is the bottom side,
Jeez.
and they are going
I'm not
clockwise.
gonna know which one's the plate and stuff. Yeah, so I'm gonna go upstairs. I'm gonna get on the computer and I'm gonna make a chart like I did with this one, where I mark everything. Draw a picture like this, or else print it out, and then come back down, and then I'll be able to follow the wire and know exactly what it's going to.
I don't want one.
Upstairs.
I don't want one like that.
Code 121. I got this rectifier, not this one. And as soon as you leave there, it has these filters, the 30, the 25, and the 20, all 150 volt, I think, because I read the one when I took it off. Somebody's selling it for $12 on eBay. Right there. It says 40, 40, and 20. That's what I got on there. And look at it. It says new. And he's got 7 available, 13 sold. Adding new multi-section capacitor, 40, 40, 20. That's what I typed in. So, $6 delivery. A lot of capacitors for $18. I would think you wouldn't buy it. When I write down where I take a wire off one of these pins, I want to say it by name. So I want to name all these. I've already numbered them, but I want to say the name when I'm changing a capacitor that it goes to pin 2 on the converter, and it's pin 3, so it's what? So to do that, you get off the schematic. This is my drawing interpretation of it, but it doesn't say heater. You got to know that's a heater. It doesn't say what this is. It doesn't label stuff. It just has the number. It just has the number. And you got to figure out if it's a grid or what it is. So then I went and printed it out. Each one will have a printout, and we'll list it here. And then you look at the number, or sometimes they have a letter right next to it. Instead of writing it out, they put a letter. I'm even putting down the one from code 125 so I can see if the wires are the same. See here they put the abbreviations. Nope, that's just the numbers again. There's one where they put the abbreviations. P for plate, H for heater, K for cathode, another P for plate, and so on. G for grid. Yeah, so some of them put the abbreviations on there. I remember it's Philco 48200, code 221, but the schematic shows code 225. That's the first. Even though it's a 5 instead of a 1, they came out with this one first, and then they quickly changed to this one because they got some cheaper capacitor tubes. Even if they had to change sockets, they went with the cheaper tubes. I want to do this because this is the 50L6GT 125, 50A5, which is right there. So now I can decide if these are the same as those on the schematic. Pin numbers are definitely different. There's 1 and 8 on the heaters on the 50A5, and here the heaters are 2 and 7. So I have to see what I make of this so I don't write the wrong name on the paper. So I'm concerned they didn't make a 48 200 code code 201 or 121. I think they only made the schematics for the code 125 because they're so close.
And it came out first.
One for the 121. nobody seems to have it. So you have to compare the wires yourself to see if there's any difference. So I've spent a lot of beginning research, which is the same thing you'd have to do if you get something out of this video of me researching, because I haven't even changed any of the capacitors yet. So this is all the research I wanted to do. It's way more than most people would do, but at least it's done now. I know what I'm looking at when I cut capacitors out, and so the capacitors that are in there are paper. It's two pieces of foil, aluminum foil, wrapped up with paper in between that has wax on it. And I guess over the years, when the paper gets moisture, it kind of deteriorates, and then it leaks. It starts leaking. Now they don't have any fluid in them. They don't leak like electrolytics, but they leak. What they leak is they leak DC in the AC circuits. So that's where you get the static and stuff. So, and then eventually the two foils are going to touch together and they're going to short out and wreck your tubes. So that's why I've decided just to cut all the paper and all the old brown looking capacitors out of there, and even the one that's been replaced for the filter cap, for the electrolytics. Might as well just take them out. I imagine that replacement was put in the 70s, where somebody bought that replacement one. They were so cheap back then, though.
From a supply house.
So this is, like I said, gone way longer than I ever thought, just trying to research all this stuff. And so if you get anything out of it from the research that I did, well, good. And I'm sure I repeated myself, and I'm sure I'm like pulling my hair out trying to figure out exactly what I got to do to fix this radio. And then, of course, I'm so stubborn that I want to understand everything. I want to know when I'm hooking something up, what pin that is, and why that's wired that way and stuff. So that's me, though. You don't probably have to know all this. You just got to write down the one you're cutting it off from and get back on the same one. So the next video, we'll be cutting them out and see if we can get it running. And using my new tube tester when it comes, I ordered one for about $100, and hopefully I won't have to do too much work to get it working. How to pronounce it? I was calling it Echo for a while, but it's EICO. And it's model 625. The 625 is covered up right there. So when that comes, I'll finish testing the tubes. If it works, maybe I gotta repair that to get it working, and it won't do me any good. So
I got my money back for the adapter.
The other one that sold, and I would have had to bid against them, went up to about $100, and if I was bidding, it would have went more. So, and with shipping, he had to pay $120. So I only had to pay $94.50. So that's will be coming, and I'll be using it. Okay, that's the end of the video. Thanks for watching.